Short-circuit calculations are critical for many network planning tasks, for example in the sizing of switchgear, in protection coordination, and many others. The PSS SINCAL short-circuit module is a powerful and precise tool, suitable also for calculation of nuclear generation plants. 1-, 2-, and 3-phase short circuits, with or without earth connection, can be calculated according to various international standards, as well as under preload conditions. PSS SINCAL also provides a full 4-wire system model, enabling the modeling of short circuits in all phase combinations, including neutral to ground faults. Additionally, in the module multiple faults, PSS SINCAL is able to calculate any combination of faults. The general short circuit settings can now be found under Calculate Settings, Short Circuit. The available short circuit calculation standards are under Short Circuit Method. Depending on which standard is selected, additional settings for the calculation according to that standard can be entered. In this example, we will choose the IEC 909 standard from 2001. If initial load is considered, PSS SINCAL will first perform a load flow calculation, considering all network parameters, then place a voltage source at the fault location using calculated voltage, according to the IEC standard. Short circuit data type can be used to select between standard user input, minimum or maximum short circuit. For circuits which cannot be modeled by symmetrical components, a simulation based on phase values is available. In this case, an adjusted short circuit calculation can also be performed. Include motors in the user-defined short circuit calculations by ticking Join Motors. For minimum short circuit calculations, if the temperature used in the calculation of line resistance is different from values used in the standard, these can be given here. For the selection of calculation procedure of peak short circuit current, tripping current calculation type selection, the additional fault data is used to define individual arc and ground impedances for the short circuit calculations. Fault impedances can be entered for each type of short circuit, and these will be considered in all calculation methods. If 4-wire systems are considered, an additional ground impedance can be included for phase value calculations. Further short circuit settings can be defined at a network level, under Network Level Short Circuit. Short circuits are simulated at nodes in PSS SINCAL. Set to Yes to turn on the simulation of short circuits for all nodes at this network level. To calculate the neutral point current, turn this flag on. For the calculation according to IEC standard, the voltage factor can be entered at the voltage source directly. Voltage tolerance determines which C-value is used for low voltage networks. Switch delay defines the time needed for a short circuit to be switched off. Maximum admissible surge current and maximum admissible breaking current evaluate the results of the calculations. Additional fault data can also be entered for a network level. If defined, these will take precedence over those defined in the calculation settings. Data for the calculation of short circuits are also entered for individual network elements. Depending on the selection of maximum, minimum, or standard short circuits, the corresponding data will be used for the infeeder. For transformers, for lines, a short circuit can now be performed at a node. Right-click at the node and choose Calculation at Node, Short Circuit. The type of fault can be selected. We will simulate a 3-phase short circuit. Results are displayed on the network editor. The size of the short circuit currents flowing throughout the network are displayed in the branches and at the nodes. Detailed results are now provided according to the IEC standards to support your network design. For calculations according to another standard, results will be displayed according to that standard. Detailed results are available for branches or for nodes. The initial symmetrical short circuit current, used for the thermal sizing of equipment, earthing, interference, and EMC. The peak short circuit current, used for sizing mechanical withstand capability of equipment. Tripping current, effective value of the symmetrical AC component of the short circuit current at switch delay, used for sizing the breaking capacity of circuit breakers. For the insertion of an equivalent supply at this node, the initial short circuit power and the initial X to R ratio are used. For the consideration of thermal withstand capability of cables under short circuit conditions, the thermal equivalent current and the maximum tripping time are equivalent values for the maximum allowable thermal stress as given by cable data. Depending on the selected method, peak short circuit current is 0 or has a calculated contribution. It's possible to automate the simulation of short circuits as selected nodes by selecting the nodes and starting a short circuit calculation across the Calculate menu. When no nodes are selected, short circuits are simulated on all network nodes. The algorithm simulates this type of short circuit on all nodes in the network sequentially. Results displayed for each node and for all branches feeding into the node are for a fault condition at that node. In this example, where a line feeding into the node is switched open, an end-of-line fault is automatically simulated. This branch result therefore does not represent the current flowing into the node SS2A, as can be seen by summing the other branch results. It is the result of a short circuit simulated at the end of this line. This end-of-line short circuit current can, for example, be used to size protection devices at the start of the line. To see overall short circuit effects across the network, the short circuit results can also be graphically displayed in an ISO plot. The short circuit current or short circuit power can be selected to be displayed. We will take the current. Red highlights the areas with particularly high short circuit current. For the calculation of unbalanced faults, the zero sequence data for elements will need to be entered, for example from manufacturer data. PSS SINCAL integrates precision with ease of use. Transformer vector groups as well as on-load tap changes are already taken into consideration according to the standard and do not need to be modeled manually. And if neutral point impedances exist for this element, these can be entered and the zero sequence system will be automatically adjusted, in the case of transformers taking the vector group into consideration. For 4-wire systems, the grounding of transformers, generators, and even of nodes or loads needs to be looked at. Perform a one-phase ground fault. Detailed results are now presented for each of the lines in the line data representation, as well as for each of the phases in the symmetrical component representation of the network. After the performance of all relevant short circuit calculations, all results can be found in the tabular view or in the result view of PSS SINCAL. Under the section Short Circuit Overview, the inbuilt reporting functionality can provide a summary of all short circuit results. Reports can also be fully individualized through the list and label reporting functionality. Additional to the fault types shown here, any combination of faults, for example, a double earth fault, can be calculated in the enhanced short circuit module multiple faults. Furthermore, the simulation of short circuits forms an integral part of many other PSS SINCAL modules, in particular in dynamic and protection simulations. In these modules, many additional features are provided. For example, the simulation of faults along lines, or the automated simulation of faults on different locations along lines,